Hi, so today we're going to plot the given Aplan 2C by our instructor in Nav 213. So this is the Aplan 2C which was given by our instructor. So in here it has exercise title which determines the compass error using terrestrial observations. In the next page there is also a scenario description which determines that at 12:00 the vessel is the vicinity of Lagunoi Gulf by visual observation using the magnetic compass. The officer on watch observed that Sialat Point and Aguho Point in transit which bore 300. Also in here it has the initial conditions which is given that ship course is at 335 degrees per standard compass and the speed of the vessel is 16 knots. Also in here it has the performance standards and performance criteria. In performance standards, you are going to be able to determine the compass error using terrestrial objects. And for that, in the part of the performance criteria, you need to calculate the variation for 2021. Also, I have here some answers already, but I'm going to try to calculate in this video on how to give you the proper solution for compass error, deviation, and the variation for the compass. As you can see, here is the variation from the chart, which is 1 degrees 15 minutes west in 2013 and 2 minutes west. So this variation, I just copied it and transferred it to a paper so that the chart won't be messy when we're going to plot it. So copy the 1 degrees 15 minutes west 2013 2 minutes west. So by calculating the variation, I subtracted 2013 and the current year, which is 2021, so the answer is 8. Then after, I divided 2 minutes west by 60. So 2 divided by 60 equals 0.03. So 0.03 minutes west. So this 1 degrees and 15 minutes west. So the 15 minutes west, I divided it by 60. So this is the answer here. 15 divided by 60 is 0.25. So I copied 25. That is now the answer is 1. I brought down 1 degrees. Then the answer of the 15 degrees west, which was divided by 60, is 25. Then after, the 8, which was the answer from 2013, which was subtracted to 2021, is 8. And the answer of this 2 degrees west, which was divided by 60, was 0.03 minutes west. So I multiplied 8 and 0.03 minutes west, and the outcome of the answer is 8 times 0.03. So the answer is 0.24. So I copied 0.24. I wrote down 0.24 minutes west. Then after, as we all know, if same sign, we need to add. Then if different sign, we need to subtract. So they have the same sign, which is west, so I added them. So to continue, 1 degrees 25 minutes west which is added by 0.24 minutes west because they have the same sign, so we need to plus it. Same sign, which is west, so here it is, 1 degrees 25 minutes west plus 0.24 minutes west, so the equals is 1 degree and 39 minutes. So to round it off, I round it off to 2 degrees, 2 minutes west. So now we're going to get the bearing. So in the scenario description, the bearing was already given. So the given bearing was 345 degrees per standard compass. So this 345 degrees per standard compass, I just transferred it in here. So basically, I don't have a chart. I a table of deviation table, but I search it online. So the nearest in betweens of 345 degrees per standard compass in a magnetic heading is 336 degrees and 355 degrees. That's the nearest in betweens of 345 degrees per standard compass in a deviation table. So in order for us to interpolate it, there's an easy way, but also there's a complicated way, but it's much more it's not it's much more complex than the easy way. So let's start. So the given the given bearing was 345 degrees, and the in-betweens are 336 and 355. So in the calculator, you'll go to mode. Then for my calculator, I'm going to choose 3, which is stat, then 2, which is a plus b and x. So 2. So in here, we can put on the x is the magnetic headings, and for the y is the deviation from the deviation from the deviation table. So the in-betweens are 336, then 355, and for 336 deviation is 4 degrees. Then for 355 is 6 degrees. So after that, we're going back. Then the bearing that was given is 345. So 345 degrees equals it, and go to shift, then press 1, which is stat 1, then 5, then 5. So this answer is 4.94. So round it off. The deviation for 345 is 5. So that's how I interpolate the 345 degrees per standard compass, which the deviation of it is 5 degrees. It's 4.94, but I round it off to the. So by correcting a compass, if west, we need to subtract it, and if it's east, we need to add it. So 345 minus 5 equals 340 degrees. So that's the magnetic compass. So after the variation is, we got it already here, which is 2 degrees west. So now again, as I said, if west, we need to subtract it. If east, we need to add it. So because it's west, we need to subtract 340 minus 2. So the answer 340 minus 2 is 338 degrees. So this is your true bearing. So the easy way, on how to interpolate a bearing. So the given was 345. So the in betweens of 345 is 336 and 355. So the deviation of each, so the deviation of 336 is, the deviation of it is 4 degrees. Then the deviation of 355 is 6. So by adding them, you get 10. So after it, so that you'll get the bearing, I mean the deviation for 345, so you need to divide it by 2. So 10 divided by 2 equals 5. So here, it's like a checking for getting a deviation for your given kanang per standard compass. So now we're going to get the true course of the ship. So the given course was 335 degrees per standard compass. So again, we're going to need to interpolate 335 degrees and find its in betweens. So in the chart, as I said, I don't have a chart. I mean, I don't have a table, so I just wrote it down, the nearest in betweens of 335, which is 320 degrees, and its deviation is 3 degrees, and 340 degrees, and its deviation is 4 degrees. So calculate it again. To interpolate it, you go to mode, then for my calculator, for any calculator you choose stat, then stat, which is in mine is 3, and again choose a plus b and x, which is 2, so 2. So in here again, as I've said, here we're going to put the in betweens, which is the compass heading, and here is the variation, I mean the deviation in the y. So the in betweens are 320, then 340. So go to the y. So the deviation of 320 is 3 degrees, and the deviation of 340 is 4 degrees. So we're going back. So again, our given true the given ship's course is 335 degrees per standard compass. So 335 equals, then for the final answer to interpolate it is, we're going to shift, then 1, then choose 5, then choose 5 again, and the answer is 3.75. So to round it off, we'll round it off into 4 degrees west. So again, as I've said earlier, if it's west, subtract it. If it's east, add it. So 335 minus 4 degrees equals 331. That's our magnetic compass for the ship's course. I mean the true course. 331 degrees. So the given variation is 2 degrees. So 2 degrees west. Then again, if it's west, we're going to subtract. So subtract 331 minus 2 So 329. So 329 is our true course. So to start off the plot, so we got the true bearing, which was 338. So 338. So 338, we're gonna plot it to Sialat point. So Sialat point. Then next is 329, which was the true course of your ship. 329. 329. So basically the intersection of it is where your ship is. So after that, we're going to write the true course, which was 329. 329. 329 degrees. Then the speed was 16 knots. 16 knots. Bearing, true bearing is 338. 338 degrees bearing. So here it is. So this is the position of your ship. Then this is the true course, which is 329 degrees and the speed of 16 knots. Then your true bearing is 338 degrees. So we already plotted our ship's course for Aplan 2C. So thank you for watching this video. I hope you learned from me, and see you soon again.